Hello, welcome to today's video. Today we're going to be talking about specific heat capacity. I often think just the name can put people off. In fact, upon first inspection, it can seem like something that is going to be rather difficult. But let's investigate the name a little bit further. Well, we know that specific is going to mean that this thing is specific to a type of something. In physics, when we talk about heat, we're usually talking about energy. In capacity, we usually understand to mean how much. Sort of like how much can something store or hold. So if we break down the name, it doesn't seem too daunting, right? Hopefully by the end of the video, you'll feel a lot more confident about specific heat capacity. We know that when we supply heat energy to an object, its temperature will rise, and that's because all the particles within the object gain some kinetic energy. Therefore, there will be a change in temperature measured when heat energy is supplied to an object. If we do work to remove heat energy from an object, there will also be a temperature change. But this time, instead of the temperature increasing, the temperature will decrease. Okay, let's say we have a tub filled with water. For us to measure a 1 degree Celsius temperature increase in this 1 kilogram tub of water, we would need to supply heat energy of 4,200 joules to the water. Just to recap, for a 1 kilogram tub of water, if we wanted to measure a positive temperature change of 1 degree Celsius, we would need to supply 4,200 joules of energy to that water to measure this 1 degree temperature increase. And this is for 1 kilogram of water. But how about if we change the material? Remember the name specific heat capacity. So we should be thinking that the amount of heat energy we need to supply is specific to the type of material. And if you were thinking that, then you'd be correct. Let's take 1 kilogram of mercury this time. It would only take us 139 joules of energy to increase the temperature of the mercury by 1 degree Celsius. So discussing the fact that the amount of energy needed to increase a kilogram of something is specific to the material means that we can learn something about that material. For example, the more energy needed to warm up 1 kilogram of material means that there will be more energy released upon cool down of that material. We could also interpret this to mean that that specific material that takes more energy to warm up can actually store a lot of heat energy. This would be something like a heater. Okay, so now it's time to introduce an equation. Equations can look rather scary, but if we think about them, it can make things a little bit easier to understand. So the first one that I've written down is E equals mc delta T, or the second one I've written down is E equals mc delta theta. Both mean exactly the same thing. The delta theta, or delta T, literally just mean a change in temperature. So this is the change in temperature when we either heat something up or cool something down. If we heat something up, the temperature change would be positive, and if something cools down, the temperature change would be negative. And this is in degrees Celsius. The mass is obviously measured in kilograms, and C is actually the specific heat capacity. We're going to talk about units in the next section of the video. And E, or sometimes referred to as delta E with the funny triangle that's drawn for the delta T and delta theta, is actually our energy transferred or our energy change. And energy, as always, is measured in joules. Okay, so let's try and deduce the units of C, or specific heat capacity. So I want to make C the subject of my equation. So if I divide firstly both sides of the equation by m, let's see what we get. So on the left side we get E over m, and on the right side we just get specific heat capacity times change in temperature. We still want to make C the subject, so let's divide both sides by delta T. We're going to get E over m times delta T on the left hand side, and then we finally have C on the right hand side. I'm just going to swap this around so that C is on the left hand side. Nothing changes here. So now let's look at the units of this. So units of C are equal to, well, E is measured in joules, mass is measured in kilograms, and change in temperature is measured in degrees Celsius. So therefore the units of C are joules per kilogram per Celsius. So we've finally deduced that specific heat capacity is the amount of energy in joules needed to heat up 1 kilogram of a material or a substance by 1 degrees Celsius. You can think of this as how much heat energy a substance can store. Brilliant, so now we know exactly what happens when we heat up a material and how we can calculate this with the equation we've just discussed. We also now know with confidence what specific heat capacity is. So let's have a go at a few questions. So our first question is, how much energy is needed to heat 2 kilograms of water from 20 degrees Celsius to 150 degrees Celsius? So the first thing to do is underline the important points in the question. So because we know this topic is specific to the type of substance, we underline water, we underline the mass, and the other important thing is the temperature rise. So we calculate the temperature change by doing the final value minus the initial value, and we get 130 degrees Celsius for our temperature change. The heat capacity of water should be given to you in the exam, and this is 4,200 joules per kilogram per degree Celsius. The mass that we are given in the question is 2 kilograms. So to calculate the energy, we just use our equation E equals mc delta T and plug in the values. 2 kilograms, 4,200 joules per degree Celsius, and a temperature change of 130 degrees Celsius. If you type this into your calculator, you should get 1,092,000 joules. Okay, let's have a go at a different type of question. This time we want to find the specific heat capacity. So, an empty 200 grams aluminium kettle cools from 115 degrees Celsius to 10 degrees Celsius and loses 19,068 joules of heat energy. What is C for aluminium? So the first thing we need to do for our question is underline the important bits of information. So that's the mass, which is 200 grams, the temperature change, which is from 115 degrees Celsius to 10 degrees Celsius, and the amount of energy lost, which is 19,068 joules. The thing we need to find is C. So let's start with our equation E equals mc delta T. We need to rearrange this for C, so we must divide both sides by m and delta T. Tricky thing in the question to spot is that the mass is in grams. We need to change this into kilograms for our equation. So to do this, we divide 200 grams by 1,000, and this gives us 0.2 kilograms. Now we're ready to plug everything into our equation. So E is 19,068 joules, our mass is 0.2 kilograms, not forgetting to work out the temperature change. Well, this is just the final temperature minus the initial temperature, or 115 degrees Celsius minus 10 degrees Celsius is just 105 degrees Celsius. So if we pop this into our equation, we should get a specific heat capacity of 908 joules per kilogram per degree Celsius. Notice how we could have written a negative temperature change because it cooled down. if we had written a negative temperature change, we would have also needed to have written a negative energy loss. Both negatives would have cancelled out and we would have still had a positive heat capacity.